So this is the ninth question on Millmans theorem. So again, a very basic one. We have to determine the Millmans equivalent circuit, the simplified equivalent circuit using Millmans theorem. So it consists of parallel current sources along with resistors. So we have to determine the Norton equivalent circuit as per Millmans theorem. Okay, so here it will take something like this. Be IN and RN. So IN will be basically the addition or the sum of the individual current values, the current sources. Sign convention will be taken as per the current direction. So here, as we always do, upward sign means positive, downward flow of current means negative. So IN will be 1 ampere upward, 4 ampere downward, that's why minus, 0.25 upward and 2 ampere upward. So the net result is 3 minus 4 minus 1 plus 0.25, which is minus 0.75 ampere. That, or you can write it as 0.75 ampere downward. Current flow is downward, so it is downward 2.75 ampere. Rn is basically the parallel equivalent resistance, 10, parallel 5, parallel 20, parallel 15, which is 1 by 10 plus 1 by 5 plus 1 by 20 plus 1 by 15, which is equal to, so here it will be 1 by 60, and this will be 6, this will be 12, this will be 3, and this will be 4. So it is 60 by, how much is 18, 25, and that will be equal to 2.4 ohm. Okay, so Rn is equal to 2.4 ohm. Okay, so this is the simplified Norton equivalent circuit for this circuit diagram. Okay, so this is the 10th question on Millmans theorem, which we'll be discussing. So here, if you see, it's kind of a different from the questions which we have discussed so far. So far, the questions which we have solved related to Millmans theorem, either there were combinations, multiple combinations of this kind of a setup, that is voltage source along with resistors connected in series, or current source along with resistors connected in parallel voltage sources or current sources. But here it is slightly different. It involves a mix of two. So here there are two ways which you can proceed. You can proceed the Thevenin way or the Norton equivalent circuit way. Both of them will be correct because it can be changed from one way to the other. So here the thing which we have to use is source transformation. I have already discussed about source transformation in basic circuit analysis, so you can watch the videos in the circuit theory playlist. So here what we have to do, convert this current source into a voltage source using source transformation. So here the circuit can be redrawn as this 6 volt 4 ohm, and this will be 2 ohm and 2 volt. This we have converted this 1 ampere 2 ohm arrangement into this using source transformation. So now we can use the Thevenin equivalent circuit approach to determine the simplified circuit. VTH, RTH. So VTH here will be V1 by R1 plus V2 by R2 divided by 1 by R1 plus 1 by R2. So that is here 6 by 4 plus 2 by 2 by 1 by 4 plus 1 by 2. Okay, so that here is equal to 4, 6 plus 4, here it is also 4, so 1 plus 2 is equal to 10 by 3, 10 by 3 volts. So VTH is equal to 10 by 3 volt. Now RTH is simply parallel, 4 parallel 2, that is equal to 1 by 4 plus 1 by 2, which is equal to 1 by 4 plus 2 equal to 1 by 3 by 4, which is equal to 4 by 3 ohm. So RTH is this. Okay, RTH is equal to 4 by 3 ohm. So this is the Thevenin approach. Another thing which you can do is go the Norton way. So here also you have to use source transformation, but here we have to convert this voltage source into a current source with a resistor connected in parallel. So in that case it would be, the circuit will be something like this. Okay, current source, resistor, again a current source and a resistor. So this one is 1 ampere 2 ohm, okay, 2 ohm and 1 ampere, okay, 2 ohm 1 ampere, that stays as usual. But here to convert this voltage source and resistor series connected, we have to convert it into a current source and parallel resistor. So this is 4 ohm, that will be fixed. Okay, this is 4 ohm, but this current value will be 6 by 4, that is 1.5 ampere, 6 volt by 4 ohm, which is 1.5 ampere. Okay, so here we have to convert it into the Norton equivalent circuit. Rn, In. In will be simply both the currents summed together, that is 1.5 plus 1, that is equal to 2.5 or equal to 5 by 2 ampere. Rn will be the usual, Rn will be equal to 4 by 3 ohm, equal to RTH, because the same way they are calculated. So In is equal to 5 by 2 ampere, Rn is equal to 4 by 3 ohm. Suppose you have to convert this Norton equivalent circuit into the Thevenin form. So simply we have to multiply In and Rn to get VTH. VTH will be In multiplied with Rn, is equal to 5 by 2 into 4 by 3, which is equal to 10 by 3 volt. See, here we calculated VTH is equal to 10 by 3 volt, the same way. So here the choice is yours. Whichever way you want to proceed, that will be correct. Suppose you want to go the Thevenin way, convert this current source and resistor connected in parallel into this form, voltage and resistor connected in series, or you can convert this arrangement, this voltage source, into current source using source transformation, and you can construct the Thevenin equivalent circuit or the Norton equivalent circuit, and then you can apply source transformation to convert Thevenin circuit to Norton or Norton circuit to Thevenin. So it's up to you, whichever one way you want to proceed, you can go. Okay,